Hey, Melissa.
Hey, Jim.
We've got some questions.
We do?
From our listeners and from all over the globe, pretty much from on the internet.
Awesome. I love that.
And the good news is I think that almost all of them are about chemistry.
Almost all of them.
Yeah.
Well, the good news is that I actually know some stuff about chemistry.
Oh, nice. That's good because I was thinking I got all these questions. I can't answer any of them at all.
I bet you could answer some.
Yeah, I mean, I would not trust my chemistry off the cuff, but we've got some really interesting ones. One about shave ice. We've got some about weed killer, glyphosate.
Nice.
We've got one about rinse aid, that stuff in dishwashers.
Mm-hmm.
So kind of a lot.
Yeah. Well, let's get into them then.
Let's do it.
Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life.
The podcast helps you understand the chemistry of your everyday life.
Bonus edition.
Yes.
Ask a Chemist edition. Hard to change that in my brain.
Yeah. Yeah, me too. Bonus is quicker, obviously.
Yeah.
So.
Well, what questions do you have for me?
Well, let's start right off the top. This one's from Justine, one of our Chem community members on Patreon.
Yes. Hey, Justine. What up?
Here's what Justine said. I missed the Ask a Chemist request, but here's mine. We are in Hawaii. Which so jealous. How does the temp of the block of ice affect the fluffiness of a good shave ice? Not mainland shaved ice / snowballs or snow cones. Important distinction. So that it shaves light and fluffy rather than fracturing or chipping off in chunks. Or maybe it's a special method of freezing it with certain clarity or lack of air. Thank you. I think it's likely.
Wait, that's my response.
That's your part. Sorry. Thanks.
I also think that was not from Justine. I think that was someone on Instagram, maybe.
Oh.
I remember seeing that on, sometimes I'll do little questions on Instagram.
Yeah. I thought the next section below was part of hers too. So anyway, well.
Whoops.
Justine's probably listening to be like, I don't think I am.
Sorry,
am I in Hawaii?
And I don't know if I have the name of that person. So
mysterious Instagram person. What a good question. Sorry, we didn't give your name. That does happen when we get DMs and stuff like that on Instagram. Sometimes it's hard to find who asked it. So anyway, we want a username if we can find it at some point.
So, but back to the question.
Yes.
About the shave ice versus, the mainland shaved ice snowballs. Have you had these before?
Yes. I mean, I have had, yes, I have. When we were there in May, we had shave ice, and I don't get the mainland version of snow cone, that kind of stuff super frequently. Mm-hmm. So I wouldn't say I'm great at explaining the difference. I think if I was a frequent shaved ice or snow cone person here in Texas and then had come over there, I could have a fresh comparison for you. I do not, unfortunately.
So I've not had them both, but my guess is that if the texture is really different, there's two possibilities. Mm-hmm. And one is simply the shave version is different. Mm-hmm. So are they literally shaving ice in really thin layers so it's powdery like snow? Versus I think a lot of snow cone places here actually kind of crush the ice rather than literally shaving it off.
Yeah.
And then the other thing is ice can freeze in different, some different textures, which we experience with snow versus sleet, right? So water can freeze in different ways. How crystalline is it? That kind of thing comes into question. That's about how quickly it freezes. But the reason I don't think that that's it is because it seems like it's a block of ice, not snow that then they're making, and they shave it off to give it that texture.
Right.
So that's my guess, is actually that it's not about the way that they freeze it or anything like that. I bet it's about the mechanical actual getting the ice off in that fluffy texture.
Yeah. Yeah, that sounds, that would make sense.
Yeah.
The fluffiness is definitely unique. I think what's hard is that even here we have some that are crushed ice and some that I think is trying to mimic this shave ice concept. So I'm sort of like, seems to be this spectrum of the ice texture rather than like a distinct like hard, crunchy, and soft over here, nothing in the middle.
Yeah.
But I definitely remember the one I had recently being super fluffy, snowy.
Like snow.
Yeah.
So there is like, if they could recreate the process of snow where it's like this very slow freezing crystalline thing, but it's hard for me to think that that's what they're doing. I feel like that would be challenging to recreate, but I've never had it.
Yeah, that place, there's a place over on Malone and University.
That used to be the popsicle place.
Yeah, which I do miss that. But they are particularly a shave ice place, meaning that, not that our opinion is one of, we can't really vet it, but they are trying to do exactly this kind.
And have you had it?
No, but we could do some experimenting.
That could be fun behind the scenes.
Yeah. Go see what you think and maybe take a peek in there with a window and see if you can see anything about the machinery that sheds light on it.
Or say, hey, we're a chemistry podcast. Can we take a video?
Yeah. Because I've been in one of those before, but I don't remember what they called their kind. Like if it was like shaved ice or snow cones or whatever.
Yeah.
But I've seen inside of one of those shacks before, but I don't, didn't have my like scientific hat on when I was there. So
mistake. So it's really Jam's fault we don't have a satisfying answer to this.
Yeah, man, dang it. I mean, not that I would have been able to like really capture that and tell it to you in a way that would have allowed you to answer it. Who knows?
Yeah, maybe.
Yeah. Interesting. Okay. So more research needed, maybe.
Yeah, for sure.
This one seems to definitely this time be from Justine. Who knows which questions? We may just always fill in the blank that Justine asked it if we don't know who asked it. This is for sure from Justine, one of our chem community members. My sister just moved into a new apartment and it smells like cigarette smoke. Ooh. The management office said they would do an ozone treatment to try and get the smell out. How does this work?
What if just anytime we couldn't find the name, we just always said Justine from Patreon? Yeah. Sorry, I was thinking about that.
Everyone loves a good callback, a good recurring joke.
Yeah, absolutely.
Yeah.
Okay, so Justine, about the ozone. Actually, funny enough, we just bought a house and it has a particular smell, old person smell. And in the garage there was a different smell, which I don't know. When you buy an older house, it can have all kinds of smells. And we did an ozone treatment and it worked really well. Although Mason thinks now it has a different kind of chemically smell, but I think it smells like kind of more neutral now. But to answer your question, I'd like to do a deep dive on this, I think. But the short answer is that ozone is pretty reactive. And so ozone very likely comes into contact with some of the smoke smell causing chemicals, the things that leave that like acrid smoke smell, and it will react with them and make new molecules. But what's difficult about ozone treatments and some of the questions that I've seen when I was researching it for myself is then it can make new smaller chemicals that could also be bad for you. Very similar to what we talked about with the pig pen effect on the airplane. That you're like, okay, well, just because we don't have the things that smell bad anymore, is that much better for you? And so we actually only did it in our garage. And then we were able to air it out completely with a fan. And so a lot of those other volatile organic compounds that might be more questionable, we were able to sort of eliminate them more so because it was in the garage. There are other areas of our house that also smell kind of weird, and we have chosen not to use it in those areas. But also it can be pretty dangerous. Like, it's not good for you to breathe ozone. And so you have to be really careful about turning on the ozone machine and getting out, if it's going to be producing ozone in a high enough concentration. So, but it does do really good things. Like we have a friend who lived in a smoker's house and I've been in their house and had no idea.
Yeah. Yeah. And he went hardcore. He did basically kind of every trick he found online that was may help.
Yeah.
So it's ozone. He did several of those machines at different parts. He like did vinegar on like a wash on the walls and ceiling and stuff. And maybe one other thing, but I was like, he also just, after all that, then painted.
Yeah.
So it was like, anything that's left now, hopefully is trapped behind a layer of paint. But
yeah, we had some, I think it was like in the floor or something, because it was coming through after we had painted. So it was like, ugh. But yeah, it's a lot to get out. So, and the idea of living in a home that smells like that is probably worse for your health, honestly, than the potential side effects of the ozone. It's like, which one are we going to do?
Yeah.
But I would say the basic idea behind how it works is basically it does oxidation reactions. Like it gives oxygens to organic molecules and sort of breaks them up. But if I was your sister, I would probably be sure to air out my apartment really well afterwards. It very likely will work. It might not be perfect, but it'll probably reduce the smell. If they do it correctly, which is hard. Everybody has to evacuate and you have to run it on, like let it just generate in an enclosed space for several hours or whatever. And then after that, open up the, everything and air it all out kind of thing.
Yeah.
So
interesting.
That's my thought. That's my chemistry off the cuff.
Off the cuff.
And I don't know if we've said that lately, but for these episodes, I try not to do research. I try to just share whatever I'm thinking, like based on what I know in the moment. So it's not as, we don't have references. It's not as in-depth as an article. I just try to as an article, sorry. It's not as in-depth as like an episode where I'm teaching a traditional lesson.
Yeah.
But I try to just draw on what I do know to provide basic answers that are kind of like quickly satisfying. And then if we need to go more in depth, we can.
Yeah, as if you're able to like sit across from Melissa at lunch and she has not had a chance to actually like research your questions and you're just having a conversation with a chemist.
Exactly. Yeah. That's what it's like.
This next one's from Jeff Bennett. I recently listened to your episode on glyphosate and thought maybe I could
That's the weed killer.
Oh, yes, the weed killer. Yes. If you've not listened to that one yet, or it's been a couple weeks and you forgot that that's the particular weed killer we talked about, and thought maybe I could contribute something. First, applying glyphosate in the regularly available strength, which is less than 20%, will likely not work. The arborist can, assuming they are licensed, get the proper strength. In my work, grassland and stream restoration, we generally do with triclopyr. Is that how you say that?
Triclopyr, maybe?
Triclopyr for cut stump treatments, as it is selective to broadleaf plants. My training is in geochemistry, and I have to look this stuff up every time. Finally, I wonder what the effect of glyphosate and other broad-spectrum herbicides might have on our microbiome. Thanks for the show. Just found it and we'll listen more.
That was great. That was great insight. I feel like there wasn't really a question other than the wondering at the end.
Yeah.
But I did share this email with our friend Grant, and who asked the question originally, and he was like, "Can I email this person? I have so many questions for them." So that made me laugh.
Yeah.
And then I forgot to respond, and he said, "Please, it's all I think about," and sent me like a crying emoji. But the question at the end about what impact glyphosate has on our microbiome, that's something I think about a lot, because it's like there's lots of questions lately in colon cancer, where there's increasing incidences of colon cancer in people our age. And it used to be like people over the age of 50, but now it's like one of the leading cause of cancer related deaths. I think it's number 2 for people under the age of 40, I think. And it's really confusing. Like a lot of gastroenterologists are like, whoa, what's happening here? And so I'm wondering, is it our lack of fiber? Is it a processed diet? Could it be from these like the residues of glyphosate? We don't really know. So the question he asks is, how do you think that impacts our microbiome? I'm like, yeah, I mean, maybe it does, but we just don't know yet.
Right.
So that's a thing that I wonder about. But we definitely have to do more research to know for sure,
Yeah.
I wish we could just know what's happening in our microbiome, you know?
Mm-hmm.
But yeah, I thought that was good, interesting info. And our friend Grant is trying. I think the last I heard is he's trying with the strength he could get to kill some of the hackberry trees, and he's leaving some of them since they're native. And yeah, so that's the update on the hackberry saga.
Yeah, one of the ones I saw, I went and viewed the situation in person. That's not the whole reason I went over there. I was just there hanging out with Grant, and he was showing me around what he had done. And one of the hackberry trees that isn't quite messing the fence up too badly, he's just leaving. Mm-hmm. It's like very, very fully grown and everything. But the ones that are particularly intersecting him and his neighbor's fence are the ones he's the most worried about. And he'd done like drilling a lot of holes in it and all that kind of stuff. And yeah, it was just crazy.
I do feel like drilling a lot of holes in it might help with the regular strength one if you're like really attacking it.
Yeah. And yeah, I was thinking that too. And if there were a couple of areas where he was like, and even if I kill this, like it had integrated with like the fence. So it's like, how long is it take for this wood to sort of rot away so I can actually like pull it off? It was very interesting.
Yeah.
So I had not really, I maybe had heard about those trees. I don't really remember, but
yeah,
he's got them in abundance, which is interesting.
I think I probably do too. We just purchased a house and my yard is overrun with trees, and I'm like, this is good for the birds, and I can't care about it right now. Yeah. When you first buy a house, there's so many other things to worry about.
For sure. Yeah. And I do feel like it's like, yeah, I guess there's some trees that can get out of hand and cause problems, but it's like, in general, I'd rather have trees than not trees.
Yeah.
You know, it's like,
yeah,
even if it's not my favorite kind, I'd rather have it than not.
Yeah, for sure.
This next one also about glyphosate, the weed killer. This is from Craft Zion on YouTube. Glyphosate is in the food supply. It's not just farmers affected. They bioengineer crops to be resistant, spray for weeds, then at harvest time, spray the crops with enough to kill the crops. Results in a more evenly dry crop. They found glyphosate in humans in countries where it is banned. Guaranteed it is in you. There is a test for it if you are curious. You also didn't mention the research that says glyphosate is an estrogen mimicking endocrine disruptor. It's been implicated in breast cancer and a 30% decrease in sperm count. One thing I'm unclear about that you mentioned is the water soluble part. I've never heard about that. Are farmers changing glyphosate to make it more water soluble before spraying it on crops? Also, if exposure to acid creates the water soluble forms, wouldn't that happen in your stomach? This is actually the first video of yours I've watched, and I really enjoyed it. Baking soda vinegar brought me here.
That's nice.
Yeah.
Okay, so I think that well, there's like a few parts to this question that I feel like I want to respond to. The first was some facts that Craft Science shared about like it's in the food supply. It's not just farmers, which we talked about that some, you know, but that I thought that farmers probably were the most likely to have the significant effects to being exposed to it long term, you know? And then also, I don't know about some of the research about it being estrogen mimicking endocrine disruptor, or like, is it implicated in breast cancer? Does it really cause a decrease in sperm count? I didn't find research that said that it definitely did or that it definitely didn't. The best, most reliable things I could find were just that it is rated as a likely carcinogen, but it's like the lowest concern, similar to red meat. So there's just not enough information yet that we can for sure say, yep, it definitely causes these or it definitely doesn't. So, but if there's some, I'm totally open to reading about that. If you have some of the peer-reviewed journal articles that have that research, I'll totally look at it, but I just didn't find them when I was looking. But it's also hard because there's only so much you can fit in one episode. You know, so it's like, if I hunt down every single little fact, it's like, oh, there's a lot. But the main thing I think that I wanted to talk about in that one and the USDA organic one was, okay, well, what is the thing that we need to be worried about? And for most Americans, it's eating enough vegetables.
Right.
So, but then the second part about it being water soluble, I think it's often formulated in a way that's already water soluble. I think it's sold in a way that's water soluble. And if I remember, the chemical structure of glyphosate has a lot of oxygens bonded to hydrogens. And in that state, it should be already, I guess, let me kind of go back. Usually when things are soluble in water, the basic idea is that their intermolecular forces can interact with each other. And intermolecular forces are literally just, if you have two molecules, are they attracted to each other or not? And if they are readily attracted to one another, you can kind of classify that into some intermolecular forces. And we've done different types of forces that attract them. We've done several episodes on that. But one kind is a really strong attractive force called hydrogen bonding, or hydrogen bridging is a better name for it. And glyphosate has oxygens bonded to hydrogens, which are really good for that hydrogen bridging thing to happen. And water does too. Hydrogen bonded to oxygen. So I would expect them to be similar enough that they could interact pretty easily. So I don't remember the specific thing that Craft Science is talking about, like what we said about it being acid or not. But just looking at the chemical structure, I think that it should be already able to interact with water. But all that to say, good questions, good thoughts. And I'm really excited that baking soda and vinegar brought you here. That's really fun.
Nice.
So thanks for sharing that, your thought, and welcome to the YouTube channel.
This next one's from Jeanette N. What is rinse aid that we put into the dishwasher? How toxic is it to the water supply?
So I don't use rinse aid in my dishwasher. Do you?
We do some, like we've had times where it'll feel like, wow, these are super like water spotty or whatever. And so we'll buy it, but we don't have it every time. And I'm not sure I'm good at like refilling the thing, you know?
Yeah.
So I don't really know. Yeah.
I've never used that. Maybe I should. This is Jeanette, who's from our community also.
Yes.
And she's asked that in a few different places, like in our email. I've seen that. And I guess it came through also on a YouTube comment. And so I'd like to actually do a deeper dive into this where I look into what it is and, try to pay closer attention. My guess is, so it's supposed to keep it from water spotting?
Yeah. And I think the water spotting, and then in general, like, my guess is there's something about depending on your water in general, like, because not always water just spot. It's like a fogginess on things that I could see being just like the water evaporated, and there's just just a film of
salt or something.
Yeah, whatever minerals are in the water.
Interesting. Yeah, but minerals that are in the water should go away with just a quick water rinse. So if they're not coming out the water rinse, unless it's being etched into the glass, I guess I wonder what that is. But another question I have is like, is it interacting with the water to make it less likely to leave something behind, or is it causing the water to evaporate more quickly or something?
Yeah.
So I think I would have to look more in depth into this. I feel like I'm not giving satisfying answers on this this bonus episode, but this is what it's like when you have coffee with the chemist. Is I try to only come out strong on things that I know for sure about.
Yeah.
And I've actually never used rinse aid. So, but I would guess it's not super toxic to the water supply because the water supply is treated. So at least the water we drink. So I would guess it would probably be okay, but I can definitely look into it. I just didn't want Jeanette, I don't want Jeanette to think we're ignoring her.
Yeah, for sure. And I guess there's also the concern of if it's toxic to the water supply, do we want to be putting on our dishes, which we will then be eating from and drinking from? Yeah. So hopefully they've used something in rinse aid that is pretty safe. And if not, then I will not be using it anymore. But
we know that we know that companies do sneaky things.
Yeah.
Sometimes.
So. Yeah. I'm wondering too, like we have this stuff that is like for cleaning stainless steel stuff. And I think in those cases, it has like a very slight like oil kind of film it leaves on purpose, which does give it like a better finish instead of like a kind of drier.
Almost like cast iron.
Yeah. So I wonder if there's any chance that that's part of it, because it's incredibly like, kind of like oil is. It's very like thin.
Yeah.
You know, like if some of it drips somewhere, it like just kind of like doesn't beat up.
Yeah.
It just like wants to just like run, and I don't know. So it seems kind of oily to me, but I haven't actually like touched it, so I don't know.
Interesting.
It'd be interesting if that was really all it was. It's like, yeah, we're just coating your dishes.
Well, that was something I wonder. That's what fabric softener is like, you know, a layer of chemical essentially that feels soft to you on your hands. And so something I thought when I was like, oh, would it make it evaporate from the dishes sooner? Are they interacting with the water? Is like, if I don't know how it would put oil specifically on the dishes, but that would keep the dishes from interacting with the water. And so if you could do like a water rinse and then an oil coat and then the final water, it wouldn't stay on.
Yeah.
But I don't know how you'd actually do that.
Yeah, interesting.
So I just, it's hard for me to think. I don't know.
Very interesting. I've never wondered about that. So thank you, Jeanette.
Yeah, this is just like wondering aloud with a chemist this week.
This next one is from Yifat on YouTube. And I'm sorry if I butchered that pronunciation. Yifat. Hi, thanks for all the cool, important things that you make accessible for everyone. I have a question about everyday chemistry, and maybe you could answer this on the podcast. What's the difference in the soaps we use? Is there a real difference between shampoos, body wash, hand soap, facial soap, etc.? Or that you can use one of them for all purposes? Thank you again.
That's a great question.
Totally.
So I think I've told you this before, but when I had to do a reading test in like 4th grade or something, there was a whole excerpt about how all shampoos are soaps, but not all soaps are shampoos. It's kind of like how the like all squares are rectangles, but not all rectangles are squares idea.
Yes.
And so I always think about that. It's just one of those things that you're like, it was just a reading test. You weren't really supposed to take that information away, but maybe that's a sign of my early affinity to chemistry that I was like, what? That's crazy. And that makes so much sense because I use soap all the time, but I don't want to use it in my hair. So I will say that all the things you mentioned, like soap, face wash, what was the other stuff? Hand soap, face wash, shampoo. All those things do the same thing in that they are meant to get rid of dirt and grease. And so they will surround those nonpolar molecules like we talked about and be rinsed away. But they are different in their formulation. So some of them are meant to be gentler, so they might just take like a surface layer off. I know that formulation chemists do things that like what they add or don't add into stuff for your hair because it's the chemistry of your hair is different than the chemistry of your skin. And so I think when they're formulating those things, they take that into consideration. And it's similar to how like, okay, so the dish soap that you put in the dishwasher is not the same as like the dish soap, the Dawn dish soap that you use to like clean your dishes by hand because it would suds up like crazy. And so it's in their basic function of removing grease. Yes, all of these are doing the same thing. But can you use all of them for the same purpose? No, because they have formulated that thing to take off the grease in those specific conditions for a lot of the cases.
Got it.
So it's like, the soap I use on my hands, I think, is a little bit of a harsher chemical than, not harsher chemical, but maybe it still has more lye, or maybe it's meant to take off more oil than maybe the stuff you would use on your face, or you know, something like that. So that is my guess, is that the formulation chemists are taking into consideration where, in what context will this be used, and they add other things to support the use in that space.
Right. Like a dish soap, which would be an extreme example because it's not a shampoo or a body wash or whatever, is, of course, when they're formulating it, hopefully they're thinking, oh, this is going to interact with like straight up oil and grease more than like any other soap.
Right.
Of course, we have oil and grease and, you know, oil on our hands and in our hair and all that stuff, but not in the amounts from when we've cooked something.
Right.
So yeah, I guess that is like the extreme example, but I see what you're saying too about just face or hair or hands, that hopefully there is a difference.
Yeah.
And that there's a good reason not to just use one.
But they could be tricking us all.
Yeah.
But I don't think that they are.
Interesting.
I feel like I learned some about that whenever we were, when we partnered with that company that you really liked.
Oh yeah, Formulate.
Yes. Yeah, we talked with their formulation chemist, and I asked her some questions about like, how do you learn all of this of what needs what. It was really interesting.
Yeah, I wonder too. I had a roommate who, forever ago, who is very, 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 very frugal. He only ever bought a huge thing of the like 3-in-1 or 4-in-1 like soap, where it's like body wash, shampoo, face wash,
conditioner.
It said conditioner too, which I was like, can it really be conditioning? But anyway, that's all he ever got. And yeah, he definitely was saving money. But I always wondered, like, is it doing all these things equally well?
Were that person's initials MB?
No, that person's initials were DB.
I don't know how to who it is.
Okay. I'll tell you later.
I do think though that I will say that one of the things the formulation chemist talked to me about was oftentimes when you use the soap to get grease off your hair, it can like lift up the like little follicles along your shaft. What is that called? Along your hair shaft, where they like. Oh
yeah, those like kind of
where they like kind of break out, and then conditioner smooths them back down. It like changes the charge of the hair.
Right.
So that was interesting. I don't know. I feel like a lot of cosmetics is a little bit of a black box industry secret. And it's been hard for me to feel like I have a good grasp on the chemistry behind that, because there seems like there's a lot of smoke and mirrors. So I think this is a good question. My instinct is to say, because there's some that you can see a difference for, like dish soap and dishwasher detergent are definitely different. And using them in that same situation is not going to go well, trading them out for each other. So I feel like there's definitely some reasons for some. There are others that I would like to learn more about before I can say for sure. But I feel like there's probably reasons. And shampoo and conditioner chemistry is one of those.
Very good question. Wow. Okay. This next one is from Sienna on Instagram. I feel like we've seen this name before, and I had the same question.
I think so too.
Would you rather drink bleach or gasoline? Assuming this is hypothetical and it won't kill you.
I know. I was like,
ooh,
that is tough. I think I might try to find a loophole and say I'll drink bleach in the super small amount where it'll just purify water. And then I don't have to just drink straight bleach.
Yeah.
I just hate the way the gasoline smells.
Yeah.
So my instinct is bleach, but I'm like, it seems miserable. I don't love how it smells either.
Yeah, me neither.
Is it doing no damage at all, do you think?
Such a good question. I don't know.
I feel like bleach would do, if in this hypothetical, in real life, bleach would do more damage on the way down, I think.
Yeah.
But I feel like if neither of them is going to kill you and but you can still feel the side effects, then I might go gasoline, even though it smells so bad, because I think it would mess less up on its way down.
That's so interesting. I mean, I almost would have thought the opposite, not from a chemist's point of view at all. Just thinking, one is like this incredibly like flammable, like destructive, like thing that just seems like we don't handle it ever. Like we're really never handling gasoline for good reason. And it like dissolves like cups and stuff. Have you ever experienced that? Whereas bleach doesn't do that. Not that it's not bad, and clearly the bottles say like don't ingest this and stuff, and like you don't want it on your just skin. But because we're using it all the time for like laundry and things, it feels so like so much more every day
Yeah.
and it doesn't dissolve plastic cups. It just feels like if I have to do one and I didn't have a chemist I could ask, I would probably go Bleach, because my thought would be, I've watched what gasoline does, and Bleach, there's nothing to see.
But it dissolves plastic because they're both like non-polar. Is my thought.
Yeah.
So I think the gasoline would interact with our insides less, but bleach is like super corrosive. Like if you get it on your skin, sometimes it feels slippery, and it's like it's like actively corroding your skin. Interesting.
Wow.
Whereas gasoline, I think, gets on your skin and it feels weird because it's oily.
Yeah. Also, the potency of, like, they both smell bad, but the potency of gasoline, I think, makes it. I would have a hard time even getting it down.
I think so too. I do think that's why I was almost like, maybe I'm gonna take bleach. I think,
and then it would just be like the fumes of it would be just like kind of like in your mouth and nose and stuff forever. Like, what would you even do? How'd you get that out?
Whenever I get a little bit on the bottom of my shoe and then I have to drive, I'm mad.
Mm-hmm.
If it's like, if like somebody spilled a little bit, or one time I got it on my clothes. I don't remember what happened. It was like, I pulled the thing out and there was like a few drops and it got on my jeans, and I was driving for like an hour and I was so mad.
Yeah, that's awful.
But I really think it would cause us less damage.
Okay, interesting.
I think.
Well, to your point, not that this is this is not good resource at all, but anytime someone's siphoning gas in like movies or TV in real life, there's like always, they get like a little bit of gasoline, and I'm like, you think that one of those would have showed like, oh wow, that person's lips like melted later.
I do think that the gasoline would have long-term negative effects.
Yeah. So if you're just siphoning gas a lot.
Yeah.
Okay.
Yeah.
Which no one should be doing really a lot anyway.
But really, it's the dose makes the poison,
Mm-hmm.
I'm just wondering if neither of them can kill me, if we're like, which one would hurt worse?
Yeah.
I don't know.
Interesting.
That was a fun hypothetical. Good question, Sienna.
Mm-hmm. Okay, this one is from Ash on Patreon, one of our community members. 3 weeks ago, heard my first shout out in an episode. Oh, sorry. This was 3 weeks ago. Is that what you're saying?
Mm-hmm.
Okay. For my first shout out in an episode last night. Made me smile, but also sad because I'm so close to fully catching up. Currently 8 unplayed episodes, including community ones, our bonus ones specifically for our community members. 6 days ago, we got another message from Ash. Now I'm fully caught up, but excited to listen to the episodes weekly. So how about another shout out to Ash?
Woo, yay, Ash. Welcome.
Catching all the way up. That is impressive.
Welcome to the present.
Mm-hmm.
How does it feel?
Yeah, how were our past selves? Like, you've kind of checked in with them more recently than we have. So
yeah,
how were we doing?
Yeah, that's crazy. 2019, that was 6 years ago.
Golly, yeah.
We are. It's like almost exactly our 6-year anniversary for the podcast, because we released our first episode the first week of August, and it's August when we're recording this.
You're right. Yeah, we probably, when we were recording the maybe the sweat one would have been like our best time to have mentioned that.
Yeah.
Not that we can't now, but it is.
Yeah.
That's crazy. Yeah, because we released on August 1st, didn't we?
I think so.
Like that year, that was a Thursday.
Yeah.
Huh. Wow.
That's amazing.
Crazy.
Happy 6-year anniversary to us.
Yeah, I can't believe it's been that long. That's crazy.
I will say, when you've caught up like with a podcast like that, it feels empty.
Mm-hmm.
You're like, anytime you're doing the dishes, you're going for a run, whatever you do while you listen to podcasts, your friends are there.
Mm-hmm.
And then you get caught up and you're like, man, now who am I going to hang out with? I have to find another podcast that I'm as excited as I was about that one.
Yeah.
And it can be a hard feeling. So drop your favorite podcast that you like to listen to, other than this one, obviously, for Ash in the comments.
Yeah.
On YouTube, or, maybe you can comment on our Instagram so that Ash can get another idea.
Mm-hmm. Yeah, there was a time where I felt like I was receiving podcast recommendations like frequently to a point where you're like, okay, hold on, everyone, I can't do that. So I will be interested in checking out whatever other people recommend and drop in there. So I may or may not listen to some of those too. So
yeah, especially with moving, I like listened to a whole series in one day because I just moved by myself on Friday while Mason was at work.
I do a lot more audiobooks than I used to, but yeah, it's interesting because I'm not inundated with recommendations now. So it's like, I don't really know what's out there.
So tell Ash and us.
Yeah, tell us. Don't hold out on us. Okay, are these several all from Brian? Yes,
and this goes with our anniversary theme.
Oh, nice. Do you want to read this one?
Yes, I'll read this. Okay, so this is from Brian. If you may remember, he's who originally asked about film photography. And he said, it's not really a follow-up question, but I just want to say thank you so much for doing the photography episode. It was such a nice 5-year anniversary present, and thanks for accidentally or other ways shouting out the Darkroom group. I sent it to a few members I thought might enjoy it. Hopefully they join your subscribers, which I thought was fun.
Nice.
I know it wasn't a small undertaking, but I appreciate it so much, and I did actually learn some things about the art form I've been practicing for a while now. I swear my jaw dropped when I heard there are dormant nucleation sites in my film, a process I always found fascinating. Anyways, I'm sorry I forgot about our anniversary because I told him my anniversary gift was the answer to this question 5 years later because that's how long it took me to respond. But I'm hoping I can make it up to you. Do you two happen to have a P.O. box for fan mail by any chance? Thanks again for the years of edutainment, which I thought was cute.
I love that word, edutainment.
I know.
I have looked into the P.O. box situation. There is a cost. We could probably talk about that at some point.
I wondered.
But it's not a bad idea.
Yeah.
But, if we have it set up and we're only getting him from Brian, then we could probably find a better way to get.
Yeah, so we'll reach out to you, Brian. But I thought that was a really nice message. But also I was like, do we have a P.O. box? So let us know if you think a P.O. box would be something that would be useful to get.
Yes, definitely. If you, like Brian, are wondering something similar, then let us know.
Yeah, for sure.
This last bit here is from Ava through our website. We love when we get questions and comments through the website. Helps us a lot. Recently discovered and very much enjoy your podcast. Haven't been able to listen to the entire archive yet, so apologies if this topic's been discussed. But I was wondering about the chemistry of erasable pens and similarly invisible ink pens.
Okay, nice. Well, invisible ink pens, I think it depends on which kind you have. We used to do invisible ink where you'd write with lemon juice. Did you ever do that?
No, I don't think so.
You could write with lemon juice, but then you'd heat up the page and it would basically it would turn brown.
Declaration of Independence style on National Treasure.
Exactly.
Yeah.
And so that is definitely just the heat facilitating the oxidation of the lemon juice, I think. Definitely is reacting with the lemon juice there. Turns brown, so then you're like, is it a Maillard reaction with the heat?
Interesting.
Maybe. But for erasable pens, so here's my framework for how dry erase markers likely work, is that when you write on a dry erase board, they are formulated intentionally where as you write, they are in a solvent. There's ink dissolved in a solvent. And when you're writing down the solvent and the quote unquote ink, which is just pigment particles, are being deposited, and the solvent evaporates. So whatever liquid it's dissolved in evaporates really quickly and easily, and it leaves behind essentially a film of those pigments so that you can just wipe them away. And I'm guessing that erasable ink, and typically they don't work well with water because they're non-polar.
Okay.
And so sometimes the oil in your fingers can work well to get it off because that's also non-polar. Or if you scribble over it with itself, because it can dissolve the pigments back into the solvent that it was originally dissolved in. So I think with erasable ink pens, it probably works really similarly, where there's some kind of formula and it deposits on there. And then what you use to erase it Because usually they have like special erasers.
Yeah.
Is designed to interact with that pigment in a specific way.
Mm-hmm.
I use erasable ink pens on Rocket Books, which is this reusable journal. Have you ever seen that?
Yeah, you showed me yours. Yeah.
I love it. It's great for teaching. And that solvent is just soluble in water, like whatever those pigments are. And so I can use water to just wipe the whole page clean. And so I think they're formulated probably similarly to that.
Yeah.
So that's my answering what I think is working for dry erase markers and trying to extrapolate it out.
Huh.
So good question. And thanks for the nice things you said at the beginning, Ava. That's really sweet.
And that's all we have.
Yeah, that's all we have.
So thank you all for your questions that you've sent in. We love the questions, comments, follow-ups to other episodes we've done. So if you have one, send it our way on our website at chemforyourlife.com. That's chem, F-O-R, yourlife.com. You can find exactly where we receive questions, feedback, comments, ideas for episodes, all that stuff. Easy to find on our website. If you'd like to help us keep our show going and contribute to cover the cost of making it, like several of our patrons and community members you've heard from in this episode, you can join our super cool Chem community of patrons on patreon.com/chemforyourlife. That's patreon.com/chemforyourlife. You get an ad-free feed of the show. You get a monthly bonus episode just for y'all. A few other things behind the scenes, a bit here and there. Ways of us saying thank you for keeping the show going and keeping it free for everybody else. So we'd love to have you check it out, try it out over there at patreon.com/chemforyourlife, starting at as low as $3 a month. But if you're not able to do that, you can still help us by subscribing to our favorite podcast app, rating, writing, review on Apple Podcasts and Spotify, subscribing on YouTube, and leaving a comment over there, and also picking up some merch from our website. There's a great one-time way of supporting the show. We always like to try to, a couple times a year, add some cool new stuff over there. We still have some hats. I'm not wearing any other chemistry stuff, and neither are you. But we've got other cool stuff. Trust us. So check it out, chemforyourlife.com/store. Those are all ways you can help support the show and keep it going and help others find out about and learn about the chemistry of their everyday life.
This episode of Chemistry for Your Life was created by me, Melissa Collini, and him, Jerem Robinson. Jerem Robinson is our producer, and this episode was made possible by our financial supporters on Patreon, like Jem said. And we think it's really important to let y'all know how much of an impact that you make for us. You make it feasible to share chemistry with even more people. You've made it possible for us to keep up with the types of equipment we need to make it accessible, like getting transcriptions and things like that. So you make a really big difference. And so we want to thank every one of you by name. So we'd like to thank Chris and Claire S., Hunter R., Katrina B., Lynn S., Scott B., Stephen B., Timothy P., and Vince W. All of these are H-bonders. We'd also like to thank Ash. Welcome to the present. I was going to say welcome to the future, but Ash, Brian, Chelsea, Doreen, Elizabeth, Emily, Heather, Jesse, Latila, Rachel, all are our dipolars. And then our dispersion areas, London dispersion forces are Autoclave, Avishai, Chelsea, Sierra, Cullen, Erica, Jacob, Jeanette, Julie, Justine, Christina, Suzanne, and Venus. Thank you all so much for everything you do to make Chemistry for Your Life happen. And there are no references for this one, so you can't check our show notes for that.
But you can, yay, chemistry.
Yeah, you can. Yay, chemistry.
Yay, chemistry.